Alright, now to multiply decimals, that's a little bit different from adding and subtracting because we don't need to have the same units to multiply. Right? If I have 430 times 9,200, I don't need to line up my hundreds with my hundreds, my tens with my tens, my ones with my ones, my thousands with my thousands. I don't need to do that. In fact, with whole numbers here, we can recognize this means times 10, and this means times 10 times 10, right, times 10 twice here. All of this is being multiplied. Really what I need to do is 92 times 43, or 43 times 92, your choice. So 3 times 2 is 6, 3 times 9 is 27. Nowhere to carry it to, so start with 27. 4 times 2 is 8, 4 times 9 is 36. That looks pretty different than what I'm going to get over here. 2 times 3 is 6, 2 times 4 is 8. That's a 0. 9 times 3 is 27. 9 times 4 is 36, 37, 38. Right, these don't really look so similar, but that's because I just added the four products up in a different order, right? 2 times 3, 2 times 40. 2 times 3, 2 times 40. 9 times 90 times 3, 90 times 40. 90 times 3, 90 times 40. I did the same four multiplications, I just lumped them into two pairs differently. Once I put those two pairs together, 6 plus 0 is 6, 6 plus 0 is 6. 8 plus 7 is 15, 8 plus 7 is 15. 8 plus 1 is 9, 6, 7, 8, 9, and 3. Right? We're still going to get 3956. If I multiply these two whole numbers, I get 3,956. But 400 times 9,000 is not going to give you about 4,000. Right? This is going to be a lot bigger than 9,000. How much bigger? Well, it's going to be this number times 10, times another two tens. These two zeros also go at the end. So we're multiplying the whole numbers and then just tacking on those zeros. 1, 2, 3 zeros, 1, 2, 3 zeros. Why those zeros? Because that 0 is representing times 10. We're not literally adding 0. We're writing an additional 0 at the end, adding in a different sense of the word, because we're multiplying by 10. So I have those zeros, put my comma in, put my comma in here. There we go. 430 times 9,200 is 3,900,000, 50,000, 6,000. 3,956,000, and no hundreds, tens, or ones. There's my answer. Right? When we're multiplying whole numbers, I don't need to include all of this 0 times 0, 0 times 0. That's additional work. It makes it harder, not easier. Now, it's even more important. It's kind of your choice whether you want to do it the long way, keeping track of all of those columns, all of those zeros. I encourage you to do it this way. But when we're dealing with decimals, it's even more important that we ignore the decimal places. Now, something we don't want to ignore is the difference between a dot and a dot. Right? If you're using a math software program, it has a different button for the dot that's at the bottom for the decimal point and the dot that's at the middle for the multiplication. In my handwriting, I try to make this dot bigger to emphasize that, but you definitely want to make sure your multiplication dot is in the middle. If you were to type this for period 3, how do I show multiplication? We use the asterisk. Right? If we don't have access to one of the fancy equation editor programs, this asterisk is how we type multiplication. And sometimes it's nice to put a space in between there so it doesn't look too jumbled up. Right? So how do we do this? Again, we ignore the fact that this is 43 tenths. We rewrite this 4.3. Instead of saying 4 and 3 tenths, I want to think of it as a single number. This is 43. Come on. 43. Hello, why aren't you writing? 43 tenths times 92. Again, I'm doing 43 times 92. I can't remember what that is, so I'll just do it quick here. 9 times, or 3 times 2, 2 times 4, 9 times 3, 36, 37, 38. There you go, 3956 tenths. So I'm writing 3956, where that 6 is in the tenths place. So I put my dot, my decimal point, between the 5 and the 6. So if I write that a little nicer, 395.6, 395 and 6 tenths. Now if you think about that, 92 is about 100, so 4 times 100 is about 400. There we go. I should get about 400, not 3,900 something. A little less than 100 times a little more than 4. Well, 100 times 4 is 400, so that's in the right ballpark. Now, if you don't want to bother with writing all of this fraction business, especially when we get into multiple fractions, the shortcut that most of you learned in grade school was to write it as 4.3, even though we ignored the fact that this was tenths. We just pretended it was an actual 43. Write it as 4.3, and then at the end, count how many numbers you have, how many digits you have to the right of that decimal point. We have 1, so I make sure to go backwards to have 1 digit to the right here. It's the same thing we did, except writing 1/10 and then multiplying by a tenth. We're just doing it kind of mysteriously. It's a lot faster, but it's also less clear what's going on here. So let's do our last problem on the same page here so we can see it clearly. Trying to make some space. Instead of 4.3, let's try 0.043 times 0.92. And when we're just doing multiplication, we can use the x. But as soon as we start using decimals as coefficients, where I have 0.043x times 0.92y, we don't like that. So we can use the dot. But then dot next to dot, ooh, that's really confusing. That's one of the reasons why we really like parentheses to show multiplication. Right? Now I know it's everything in here times everything in here. I could write 0.043, 0.92. There we go. It's no symbol here in between to get confused with these dots. So that's just symbology, right? Let's get to the actual multiplying. 0.043, I don't care about whether there's 1 0 here or 2 zeros here. It's not affecting the actual multiplication. I'm just doing 43, 0.92, 92. 2 times 3 is 6, 2 times 4 is 8, 9 times 3 is 27, 36 plus 2 is 38. Same thing we've been doing for the last 9.5 minutes. 8 plus 1 is 9, 39.56. Right? 3956, 3956, 3956. It's just a question of place value. So I'm getting 3956, and if I'm going to toss these variables in here, why not? Times x times y. But this isn't 3,956, it's 3,956 tenths, or 3,956 millionths, or whatever the decimal place is. 0.043 tenths, hundredths, thousandths. That's really 43 thousandths. 0.92 tenths, hundredths. That's really 92 hundredths. If I put those dots in here, I have 1, 2, 3 digits to the right of 0, to the right of the decimal point, 2 digits to the right of the decimal point. That's 1, 2, 3, 4, 5. So I need to move my decimal point. 1, 2, 3, 4, 5. All right, I'm dividing by 10 1, 2, 3, 4, 5 times. I get 43 times 92, 3956, divided by 100,000. That's a comma, not a point here. Okay. I need this to be in the hundred thousandths place. Hundred thousandths, 10 thousandths, 1 thousandths, 100ths, 1/10th, decimal point 1. Right? The decimal point shifted over to a spot in front of the 3, so I need to fill that spot in with the placeholder 0. Just like here, I needed to put in these 3 placeholder zeros to emphasize that the decimal point was way over here. Now, we don't say 43 point when we mean 43. Right? If I just have 43, I just have 43. If I just have 3 million, I'm going to say 3,956,000. No decimal point necessary. When I write this number, I need the decimal point, but I don't need zeros past the 6. I need a 0 here to show that this isn't 3/10ths, but it's 3/100ths. So our product without the variables, 0.03, followed by 956. Or if we want to put an extra 0 out front there. Either of those are correct. If I include times x times y, if that's my problem, that's my answer. And of course, you're going to all use one color here. This is all one number. 3,956 hundred thousandths, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, 3,956 hundred thousandths times x times y. I'm ignoring what the place values are. I'm doing that multiplication. Then I'm bringing in the times 100 or divided by 100, times 10 or divided by 10 to figure out where this number compares to my decimal point. Right? A very different process to addition or subtraction, because when we add, subtract, or compare values, I need the same units. To change the units, that's where I'm multiplying. Right? To change units, I should be more precise here. To change units without changing value, we're going to multiply by 1. For these problems, when we're multiplying, we are changing the value. It's not 92 times 10 tenths. The value is going from 92 to 395.6 over, actually, leave it there. Here, instead of saying 4 and 3/10ths, if I want to think of that as 43 tenths, technically, I am multiplying by 1. So I have 40 tenths plus 3/10 to get 43/10. But you don't need to show all of this work, right? We're just seeing this as a 2-digit number in the tenths place, 43/10. I'm treating it as a 2-digit number and then just recognizing at the end where my place value compares. So don't write this even if that is technically what we're doing. It just makes it seem more complicated than it is. Okay, that's how we multiply decimals.